In this lesson, we're going to look at function notation. So equations that are functions can be written in a form called function notation. For example, if we had an equation y equals 3x minus 8, we could write that equation in the y and x form as it's written, or we could write it in function notation. And hopefully you notice that in function notation, the 3x minus 8 portion of our equation stays exactly the same. What we do though is we'll replace the y with function notation, which is f of x. So when you see this f open parentheses x, we will say this as f of x, meaning that for the function, we are going to replace or have the potential to replace x with any value into our equation. So for example, if I told you to find f of 2, what this means is to find the function called f. So we have the f function over here, and instead of x, let's replace x with a value of 2. So step 1 is to substitute 2 in for every x that we see in our equation. And once we do that, we'll simplify to get our solution. So if I'm finding f of 2, notice this f of 2 portion used to be the y part. Now instead of y, we're finding the f of x, and so we're just putting a value of 2 in everywhere we see an x. When you substitute, it's incredibly important that you put parentheses around the number you're substituting for. So instead of the x, I'm replacing x with 2. 3 times 2 minus 8. Now we simplify to 6 minus 8, which is negative 2. So f of 2 is equal to negative 2. The nice thing about function notation is that we can do this process an infinite number of times, substituting various different values for x and finding the different outputs. So we've talked about functions as being machines where we put something into them and then out pops something that we've created. So in this instance, we are putting 2 into our function, and then once we put 2 in, we simplify to get negative 2 out. So let's practice this. Here we have the function f of x equals 2x plus 5. Now I could write this as an equation, y equals 2x plus 5, but this one is written with function notation to indicate that we can put different values for x in. So if we are finding f of negative 1, then that means we're going to look for every, firstly looking for the function f, which is indicated by the letter outside of the parentheses, and instead of x, we're going to replace x's with negative 1. So I'm going to put parentheses around my negative 1. When I substitute x for negative 1, again, an example of where parentheses are incredibly important when we're substituting, so that this implies the multiplication that's supposed to be there. And now we simplify. So we find when we simplify negative 2 plus 5 to get 3, we'll finally state our answer back with the f of negative 1 equaling 3, because it is important to note that 3 will not be our output every time. It's our output when the input of negative 1 was used. So f of negative 1 equals 3. So let's add on to this a little bit. We're still using the function f of x equals 2x plus 5, and this time we're going to find f of 1, but we're also going to add 4 to it. So when you see a couple things that we need to do to the function, we'll follow order of operations essentially to simplify. So we're going to start by finding what f of 1 is. So in a sense, you can ignore the plus 4 piece right here in the beginning for just a moment, okay? So we'll start by finding f of 1. And once we find f of 1, once we get that number, we're going to add 4 to it. So that's going to look like, didn't mean to show the answer. Anyways, we have 2x plus 5. So let's find f of 1 first, meaning we replace x with 1. and we get 7. So this all represents f of 1. 7 is what f of 1 simplifies to, or outputs to. But then we have this plus 4 that we have to do to the whole value. So if I find f of 1 to be 7, I need to now add 4 to it, giving us 11. So we started by finding f of 1, getting its value to be 7, and then once we got that number is when we added the 4 at the end, giving us 11. Again, when we're stating this, we're not just boxing an 11 by itself, we're stating f of 1 plus 4 equals 11. Let's practice this one together. Now our function has changed. It's f of x equals 4x minus 5. And we're going to find f of 2 minus 3. So that means we're first going to focus on the f of 2, find that value, and whatever that number is, we will then subtract 3 from that value. So sometimes when I show this, well, never mind, let's just walk through. So our equation was 4x minus 5, minus 5. So instead of x, we're replacing it with a 2. So 4 times 2 minus 5 is 8 minus 5, which is 3. And then I'm showing that I'm bringing down that minus sign and the 3. So 3 minus 3 becomes 0. So f of 2, which the value there was 3, minus 3 equals 0. This is our answer. Okay, this problem, our function is f of x equals 2x plus 1. We are being asked to find f of x plus 3. So we're going to follow the same process where we substitute whatever is inside of these parentheses, we will substitute in for every x that we see in our function. So right here is an x, so we're going to replace that x with an x plus 3. Again, using parentheses when we make that substitution. So we were starting out with a 2x plus 1, and instead of x, we're replacing x with the x plus 3 in parentheses. Again, parentheses are crucial because we actually need to distribute in this situation to simplify. So that gives us 2x plus 6. Don't forget to bring down this plus 1 from the function itself. And the 6 and 1 can combine to be a 7, but that's as far as we can go. So we'll end by saying f of x plus 3 simplifies to 2x plus 7. All right, so let's move on to composite functions, which are functions combined together. So when we're doing these, we again will follow an order of operations. So you'll notice that with composite functions, we'll be given a few functions to work with. So every function we've seen up to this point has been called f of x. However, I can call a function g, I can call it h, but it's going to always be a letter with x in the parentheses. So G and H are just different alphabet letters so that we know that they refer to different equations. So G of x refers to x squared, while H of x refers to 3x minus 2. So if we're told to find H of 4 plus G of 1, that means we need to find the value for putting 4 into the H function. Then we need to find the value of putting 1 into the G function. And when we get those two numbers, we will finally add them together. So I will often drop a line down wherever my operation sign is in between my composite functions so that I'm keeping my work clean and separate. Oops, sorry. I keep showing the answer. So H of 4 means find the function h, which is 3x minus 2, and instead of x, we replace the x with a 4. So I'm going to simplify this all the way down to get 10. So 10 is the value for h of 4. Over here, we need to find g of 1. Well, g's function is x squared. So that means I'm putting 1 in the place of x and simplifying to get 1. So g of 1 simplifies to 1. And we were told to find h of 4 plus g of 1. So if we now know that h of 4 is 10 and g of 1 is 1, we will add the two together to get 11 as our sum of those two functions. Again, as our final answer, we'll state h of 4 plus g of 1 equals 11. All right, here's our next type of composite function. This is one where we're going to actually work from the inside out. So what this the way this reads is find g of h of 3. Notice we've got some parentheses here. So just like order of operations, we would start inside of our parentheses. So that means we're going to start by finding h of 3 first. Once we find h of 3, we will be able to replace this entire h of 3 with that number we find, and then put that value in for g. So let me show you what I'm talking about. All right, so work inside out. So h of 3 means find the h function, which is right here, and put 3 in for every x we see. So 3x minus 2 is the h function, and I'm going to replace x, any x I see, with a 3, giving me a 9 minus 2, which is 7. So 7 is the value for h of 3. Once you find the value for h of 3, remember we started with g of h of 3, we're going to replace this whole h of 3 with 7 and bring down this g. So we've simplified on the inside, now we're going to work our way out. So now that we know h of 3 to be 7, we're going to go ahead and find the g function, which is x squared. Oops, let me come over here. The g function is x squared, and so here we're finding g of 7. So that means instead of x, I replace it with 7. 7 squared is 49. So g of 7 equaled 49, meaning that the entire g of h of 3 is 49. So we work our way out. We started by finding h of 3, it was 7, then we found g of 7 to get 49, so 49 is the final output. Let's try another one like that. So this one says to find g of f of 2. Here we have an f function. F's function is over here is 4x minus 5. We should begin inside the parentheses with the f of 2. So f of 2 means go to your f function and put 2 in for every x you see. So our f function was 4x minus 5, so I replaced x with 2. 4 times 2 is 8, minus 5 is 3. So we found f of 2 to be 3. So now we could rewrite this as, instead of g of f of 2, we can replace this entire f of 2 value with a 3, which means we now need to find g of 3. So g's function is x squared plus 1 in this example. So we'll take x squared plus 1, but instead of x, we need to now replace it with a 3. So 3 squared plus 1 is 9 plus 1, which is 10, meaning that this entire expression is equal to 10. Here is another composite function. This time we're multiplying two functions together, or two functions outputs together, I should say. So here is our operation. So you may want to drop a line down your page. Oops, okay. And we're going to find f of negative 3. So that means negative 3 comes over to the f function everywhere there's an x. We're going to find g of 6, meaning put 6 in for every x in the g function. We will get those two values separately And then at the end, we'll multiply them together to get the final simplified value. So for f's function, we replace the x with 3, or sorry, negative 3. I missed the negative when I was speaking. So it is 4 times negative 3 minus 5. And g's function was x squared plus 1. In g's function, I'm replacing x with 6. So 6 squared plus 1. So simplifying these, we would get a negative 17 for f of negative 3 and a 37 for g of 6. The operation in between the two is to multiply. So once I get my negative 17 for f of negative 3 and my 37 for g of 6, I need to multiply them together, giving us negative 629. Okay, the last little application we'll have of composite functions will be to evaluate a function over a domain. And a domain, if you'll remember, is a set of your x values. So if you're given, oops, I was running out of space, but if you are given a domain, that just means you're given several different x's to substitute into your equation and simplify for. So if you're given this function, f of x equals 4x, and we're told to find evaluate the function over the domain of negative 1, 0, and 2, that means we're actually going to just do this problem 3 times. Once we're going to put negative 1 in for x, then we'll put 0 in for x, and finally we'll put a 2 in for every x we see. So let's split up the work. We have f of negative 1. If my function was 4x, then I'm replacing the x with negative 1, getting negative 4 when f of negative 1 is simplified. We now need to find f of 0, meaning put 0 in where we see the x, which is 0. So f of 0 outputs to 0. And finally, f of 2 means 4 times 2, which is 8. So f of 2 simplifies to 8. We will lastly put all of our outputs in a set known as the range for that domain. So that means we need curly brackets, and then we just bring the negative 4, the 0, and the 8 into our solution set. So there's one more like that for you to practice. We are still evaluating over the domain negative 1, 0, and 2. However, this time you are using the function g of x, which is 3x minus 9. So pause this video, evaluate for those 3 domain values, and then we'll check together. Okay, let's check. We should have gotten the range for that domain to be negative 12, negative 9, negative 3. Okay, so we are done with our lesson. However, on your homework, you are going to be asked to graph a couple functions in your calculator just to start looking at what functions look like. So I'm going to take a simple function y equals x plus 1. We could again write it in function notation as f of x equals x plus 1. And let's quickly pull out our calculators and just look at how we would graph something like that. So I am at home on my calculator, and let's go to our graphing scratch pad. In the graphing scratch pad, we're going to graph that function x plus 1. And so to input a function, we're going to hit the tab button, which is over here, 3 buttons down on the left. I don't know why mine is freaking out. There we go. And you'll notice that this gives you an option to type in for f1 of x. So that stands for f of x. It's just that it's numbering our function as the first function. So if I want to type in or graph f of x to be x plus 1, when I type that in, I'm just typing in x plus 1. So here we are. So we're going to type x plus 1, hit enter, and graph that function. If I wanted to graph a second function, I would pull up and hit tab again. And you'll notice now it's giving me the option for f2 of x, meaning that's my second function. If I wanted to go back to the first function, you can hit your scroll arrow up. If this will work. Oh, there, come on. Oh, there we go. Up one to see that one. So if I'm at f2, let's say I wanted to graph x squared, which might even be one on your homework, I'm not sure, and hit enter, you can see what that graph might look like. So I just wanted you to have a quick review of the buttons you'll be hitting to graph your different functions. If you want to clear your entire graph, then hit delete 3 times, and then yes, hit enter, and you're clear. And that's it for our lesson.